In this video, we're going to look at the observer pattern. A programming pattern is a way to structure part of your code which normally leads to the benefit of less dependencies between classes, easier reuse of chunks of your code, and it often makes it easier to make changes without breaking other features. So overall, it keeps code cleaner and more fun to work with. The observer pattern is a way for two classes to communicate without both directly knowing about each other. On the left hand side, we've got two interdependent classes. A knows about B, B knows about A. Both classes need each other to function properly, so A can't be reused on its own, B can't be reused on its own. Both are there just for this very specific purpose and need each other. The observer pattern on the right hand side though has B broadcasting out a message and A chooses to listen to this message. This means that A still gets the information it needs from B, but B doesn't know anything about A specifically. It just knows that it's broadcasting a message. Something can be listening for that or nothing can be listening for that. B can then be reused anywhere without A tagging along. It can even be reused with any of the other letters of the alphabet. I'll try and demo the concept as simply as I can. So I've got an abstract item class here which has one function on it, use, and two types of item, a shield and a sword, and when each of one of those is used it's going to say use shield or use sword. So items can be added to an inventory. An inventory is just a list of items with an add item and remove item function that prints out when something's added or removed. And to run all this from, I've just got a game mono behavior class which spins up an inventory, spins up a sword and a shield, adds both to the inventory and then uses both of them. And I've just attached that script to the main camera in a sample scene. If we play that, we're getting exactly what we'd expect. The sword's been added to the inventory, then the shield's been added, and then the sword's been used and the shield's been used. So what about if we need to add some functionality? Let's say the sword is now single use, and once it's been used it wants to be removed from the inventory. Now that's something you can do in this class here, but then that means anytime you spin up an inventory you're going to have to remember that the sword is single use. It can be done inside the inventory itself, but then the inventory is going to have to check what type of item it's looking at, or it can be done in the sword, because the sword knows that it should be single use. So we could do something like take in the inventory in the constructor, and when we use a sword we'll just remove this item from the inventory. And in our game class now we're going to have to pass that inventory into the sword. If we take that for a spin, yep, we'll see the sword added, the shield added, the sword's used, which then removes it from the inventory, and then we use the shield as before. So we're left in a state where things are getting a bit interconnected. The inventory has a list of items, including the sword, and the sword knows about the inventory. But just to display how this can be a problem, we now need a shop class. And a shop class is similar to an inventory. It's got a list of items. You can add an item to the shop and you can remove an item from the shop. So if we try and spin this up, after that we'll just create a shop, and we want to create a sword to add to our shop to be able to sell it. But we can't, because this sword now requires an inventory, which isn't very good, because we can't use our sword wherever we want anymore. This sword is directly tied to that inventory. So what can we do to get around that? Comment that out for now. Let's go back to the items. And at the top of this item class, I'm going to put in a callback. I'll say something along the lines of on item degraded. So after the first time we use the sword, we're going to call it a degraded item, which is useless in the inventory. And I've set this callback to just point to the equivalent of like an empty function. So whenever it's triggered, it's just going to call the empty function for now. And what we can do inside our sword class is to comment out this direct remove item from the inventory, and instead we'll call this callback, we'll trigger it off. So when our sword is being used, it calls this on item degraded callback, and we just need something to listen for that now and to do something. And we can do that inside the inventory itself. So when our item is added, we'll start listening for that callback. And when that callback has been triggered, we're then going to remove this item from the inventory. And we'll follow that up with just pointing that callback back at the empty function, so that we don't get remove called more than once if we're frequently calling use. So if we test that out, we can see that we're getting exactly the same results as before without directly calling the remove item from the inventory. So if we just look back over what we've done there, we've got this callback at the top of the item class on item degraded that we call from our sword. This is then listened to inside the inventory when things are added, so that we know when our item is degraded and we're going to remove it from the inventory. We no longer want it in our inventory. So this now lets us remove the reference of the inventory inside our sword. So we can now remove the inventory reference in sword. And if we try again to spin up this shop that we were doing so before, we no longer need a reference to the inventory in the second sword that we create. And if we take that for a spin, we can now see our sword is being added to the shop. So this is quite cool, because before an inventory would have a list of items and your sword would know about that inventory. Your sword was tightly coupled to that inventory, meaning that it couldn't be used in any other construct. Whereas now, we can use it in a shop, we could use it in a museum. The sword doesn't care where it's being used. So the cool thing about this is the sword is now broadcasted out this message on item degraded, so anything can choose to listen for that or not. So if you're in a shop, nothing might listen for it, or it might listen for it and choose to sell your item at a reduced rate. Your inventory can latch onto it and remove it from the inventory, or nothing can listen to it and it can just be a sword going about its degraded business. Hope you found that little example useful. It's one of the patterns I use the most for decoupling and reducing these two-way dependencies, and I hope you can use it in your project. Bye for now.